Welcome to what promises to be a very exciting debate today on a single topic, namely how much CO2 we can afford to put into the atmosphere and still stay below 1.5 degrees of warming. This debate is hosted by CICERO, Center for International Climate Research, and it was inspired by a recent paper on the topic. The paper came out in the fall and spurred quite a bit of controversy and debate. The paper was led by scientists at University of Oxford, and it also had co-authors at CICERO. Today, we are fortunate to have with us both some of the co-authors of the paper, as well as some of the most vocal people criticizing or challenging the findings of the paper. So participants in the debate today are Richard Millar, Oxford Martin Fellow at University of Oxford and first author of the paper. We also have Myles Allen, professor at University of Oxford and a co-author of the paper. We have Glen research director at CICERO, and we have Gunnar, also research director at CICERO. My name is Trude Storelvmo. I'm an associate professor at University of Oslo, and I will be moderating the debate today. The debate goes on here, but it also goes on Twitter under hashtag carbon debate. And we'll continue this event by having a discussion with Richard Millar first about the paper itself and how it came to be. So, Richard, would you mind telling us first how the paper came to be, how it was conceived?
Sure. So I guess the obvious lead into the paper was the Paris Climate Change Agreement itself, which set this new long-term temperature goal that included this high ambition 1.5 degrees goal. And a lot of the coverage following the Paris Climate Agreement was how 1.5 is, maybe already impossible, and is it really a sensible target for policymakers to have set, or is it even a possible target to have set? And this is what really prompted the paper, really, is to sort of examine one aspect of information that's going to inform that question, which is how much cumulative carbon emissions could the globe emit as a whole between now and forever to still have a good chance of staying beneath that 1.5 degree threshold.
Great. Could you then talk about your research approach, the methods that you chose, and perhaps also the main takeaways in the paper?
Sure. So our starting point was really to look at the ensemble of Earth system models, which are big models, computer models of the climate that simulate the physics in the atmosphere and the ocean and the carbon cycle, and can give us some constraints on how the relationship between warming within these models and emissions are related. And we know there's this kind of roughly a straight line relationship between CO2-induced warming and cumulative emissions from the models. And our question was really, do the remaining carbon budgets that were quite widely quoted that have come in part from this set of models, do they really make sense with our current understanding of the climate system? And if we look at how much warming models have by the time they reached observed emissions, we see a big spread. There's a spread of over well over half a degree, almost 0.7 degrees for the same amount of cumulative emissions. And one of our approaches to start with was to sort of say, okay, let's compress this sort of near-term range of behavior and look at what does this model ensemble say about warming above the average of the present decade for emissions into the future. And so we looked at this model ensemble and using a temperature definition that seems compatible with the policy documents in the run-in to the Paris Agreement, we looked at what a budget might be for a 0.6 degrees warming above the present decade, which is, using this temperature definition would be a possible interpretation of the Paris Agreement. And we found a budget of about 200 gigatons of carbon, which would be equivalent to something like about nearly 20 years at present day emissions rates, or equivalently taking emissions, in a roughly a straight line from about where we are now to zero in about 40 years or so. So these are a bit bigger than some of the previous estimates that have been made for this remaining budget for the 1.5 degree threshold, but still a really substantial policy challenge, and meeting any of these budgets requires us to firstly be able to get our emissions to absolute zero, to net zero, and secondly to improve on the near-term pledges to reduce emissions by 2030 according to the Paris Agreement. So that was one of the strands of evidence we used in our papers, and then we also looked at it from a slightly different approach, which was to say, okay, can we construct some pathways using a simple climate model that actually get to 1.5 degrees in a way that they actually succeed in having temperatures reaching 1.5 degrees and stable or going down. And we used a simple climate model to do that, and assessed a range of different possible climate responses that were consistent with assessed ranges for the important climate system parameters from the fifth assessment report, and find broadly similar cumulative emissions budgets for using that approach. So reasonably congruent with our assessment of the Earth system models.
So several lines of evidence then that suggest that we may have slightly more time than we previously thought to reduce emissions, right?
Yeah, absolutely. I think one of the things we did in this paper, which was to sort of give budgets as for future levels of warming beyond today's level, and this is something that's been done with climate projections for a long time. Climate projections within the IPCC process are nearly always given relative to a near-term reference period. Carbon budgets weren't calculated like that in the fifth assessment report of the IPCC. So one of the things we did was quite simply to almost take a very similar approach to how climate projections were made in the IPCC and apply this to carbon budgets. So to give budgets for future thresholds of warming above the present day. And of course there's some uncertainty in exactly what the Paris temperature definition might correspond to, and we use one, as I said, that we believe is consistent with the sort of policy documentation running into Paris, but there's other possible definitions, and so we also calculated budgets for various different thresholds of warming above the present decade to give some sense of the how this definitional uncertainty might affect these remaining budgets. And in all cases we find that they would be still substantially greater than those estimated from many previous analyses, indicating that there might be 1.5 might not be quite a geophysical impossibility yet, which some of the previous estimates may have come quite close to essentially implying.
Mm-hmm. Okay, so as I already alluded to, the paper triggered quite a bit of debate. Sure. You got quite a bit of media attention. Mm-hmm. Could you tell us a little bit about how you experienced that?
Yeah, we certainly did get a good bit of media attention. Well, firstly, I think we knew that I think there would be some attention to this paper, so we tried our best to prepare as best we could. We wrote our best attempt at a sort of more general communication piece around this, a blog article on the Carbon Brief website. But yes, there was a lot of media coverage, and some of that media coverage was quite misrepresentative of the paper, in that there are certain parts of the press that were arguing that our paper claimed that global warming had been exaggerated, and that the system models were wrong in how much warming they were estimating for any given amount of carbon in the atmosphere, and that's categorically not what our result was about. As I talked about before, our result is about considering budgets relative to some near-term period, and we didn't show that this is the case at all, and we've seen no evidence that is the case based on our analysis. So yes, but there was this coverage along those regards, and we thought about it and why that might have happened, and we did our best to write some clarification pieces that to sort of to balance the record and to show that wasn't what our research was about, and to sort of document that and make sure that was out there as well.
Mm-hmm. So some misrepresentation of your paper in media, right?
Yes.
Well, today,
in certain sections, some of the coverage was very good as well, and accurate and raise some interesting questions that the scientific discussion on these things always continues, and it's never fixed a fast endpoint to any of it.
Right, wonderful. Well, today we're here to continue the debate, talking about the scientific facts. All right, I think this is a good time to transition over. We'll join you for the full debate later on. And I have with me Glen Peters from CICERO. You've been perhaps one of the most vocal people in this debate in challenging the findings of the paper or criticizing the paper. Can you talk about what your main issues were?
Yeah, so my first up, I'd say, my main issue would be sort of surprise or frustration, maybe even a better word. So there's maybe 5 or 10 people in the world that really understand carbon budgets, and I mean really understand them. It's a simple approach, so lots of people think they understand them, but really understand the details, there's not many people. And everything I know about carbon budgets I've learnt from these people, and these people are the authors of this paper. So this paper comes with a lot of weight, so you really have to respect the paper. And I think it's okay to come with a new estimate. This estimate was quite big. Let's just put that aside for a minute. My main concern is really the nuance and the discussion and the sort of framing around the paper and the sort of lack of detailed discussion of uncertainties. So Richard, for example, said there's multiple lines of evidence. I would say that's not the case. And let me touch on 4 things, which are my sort of key concerns. The first one is a very technical and, in a sense, nerdy point. And in the Intergovernmental Panel on Climate Change, they called different models simple models and complex models around the carbon budgets. So in Richard's paper, they used complex models, that's an Earth system model, so these big models of the Earth system that really describe what's going on with the climate system. Very valuable models, but one disadvantage with them is they're very resource intensive, so you can only really run limited scenarios. And so the study can only really look at the limited number of scenarios, so you don't get an expression of the uncertainty. So in the paper they tried to, let's say, narrow the range of uncertainty using those complex models, which is a valuable contribution, but then you can't run the model through hundreds of different scenarios to really explore what's going on. So that's a quite technical issue, which I'll come back to. I'm sure in the next half hour or so we'll discuss the temperature data. They looked at a 0.6 temperature increase from today to 1.5. A lot of people have pushed back on that. I won't get into the details there, but if you took 1.1 degree instead of 0.9 degree, so a 0.4 degree step instead of a 0.6 degree step, that more or less describes about 2/3 of the difference in the budget. So that one number is extremely important for the paper. So the paper solved one problem, but it creates another problem, which is that temperature uncertainty. So one thing that they didn't explore in the paper, which I think is critical, is the non-CO2 emissions. So the temperature is not only affected by CO2, but also methane, sulfur dioxide, and all these other components. And that temperature contribution in scenarios could be 0.2, 3, 4, 5 degrees or something like that. And they so happened to use a scenario. They had no choice because it's a complex model. They had to use a scenario which had very aggressive non-CO2 mitigation. Aggressive non-CO2 mitigation means you have a very big, much bigger carbon budget. And that's one, taking the temperature record and the non-CO2, and you can explain the difference between the studies. So it could be that their numbers are quite correct, but they're just at the edge of what's feasible given temperature data and non-CO2 pathways. And the other thing that was, the sort of last thing I'll mention is the negative emissions. So most scenarios to get below 2 degrees require removing carbon from the atmosphere, and this sort of undermines, in a sense, the carbon budget concept because you can exceed the budget and go back down. So it becomes quite ambiguous. So it would have been nice to have much more a discussion around those sorts of uncertainties that, if you make this choice and this choice, the carbon budget will be this big. If you make this choice and this choice, the carbon budget could be this big. So I think it's still possible the carbon budget is just this big. It could also be this big, and this is the uncertainty that we have to deal with. So my frustration is the authors know this. I know they know this. I've discussed it with them, and they really didn't bring out that important nuance.
So you're basically saying if all the stars align, we could be as lucky as they suggest in the paper, but we may not.
So if we are really radical on non-CO2, really focus aggressively on non-CO2, we can have a bigger carbon budget. That's important information. Mm-hmm. If we want to look at the temperature increase from today, which I think is quite a good argument, and we agree that it's 0.6 from today, then we'll have a bigger carbon budget. And that's great, but you really need to bring out that these are the choices that you're making.
All right, so you brought up choice of temperature data set. You brought up non-CO2 climate forcers. So these are some of the topics that we'll continue to debate with the others over here. So let's walk over and join the others. All right. So I think since Glen, you had the word last, I'll let Myles comment on some of the challenges or some of the criticism that you brought up.
Yeah, well, again, as Richard pointed out, this paper was very focused on the implications of the 1.5 degree goal as agreed in Paris. And two things are interesting about that goal. First of all, it's about pursuing efforts towards 1.5 degrees. And secondly, it was in the context of a structured expert dialogue. So before the Paris Agreement actually happened, there was a 3-year period over which experts from the whole entire scientific community were contributing to the process by telling the decision makers what they thought was going on. And crucially, during that structured expert dialogue, the UNFCCC negotiators were told, we are now at 0.85 degrees above pre-industrial. So, in effect, that almost automatically defines pre-industrial and defines what you're using to measure global temperature for you. Because if the negotiators were told we're now at 0.85 and then agreed on 1.5 degrees as their goal, we will never know. And frankly, I'd rather we don't know, because it would mean renegotiating the entire agreement, what they would have decided as their long-term temperature goal had they been told we're now at 1.2 degrees, which they could have been. On one of the data sets out there, it could have been said back in 2013 that we're already at 1.2 degrees. Would they then have agreed to go for 1.5? I mean, that's assuming a very high level of naivety on the part of the UNFCCC process. They know that they can't stop global temperatures dead in its tracks. So the information about where we are now, they would recognize as very important to the temperature goals they're setting. So on the temperature question, we used a definition of temperature and a definition of pre-industrial that was consistent with that structured expert dialogue and also consistent with the IPCC Fifth Assessment Report, which of course is not a separate thing, because the structured expert dialogue was deliberately designed to be building directly on the Fifth Assessment Report. So we make no apologies for that. I think that was still the right call. I think as a scientific community, we need to work with the definitions of global temperature that the policy community are using. We might argue that they should change their definition, but in the end, it's their definition, not ours. It's a bit like defining the rate of inflation. Economists argue that there might be a better basket of goods that you could use to define the rate of inflation, and it would give you a different number to the one that the central bank publishes. But the central bank has to keep using the same number, otherwise you get a sort of lurch in the rate of inflation from one year to the next, which is nothing to do with what's actually happening and just due to redefining it. So I think if we are going to redefine global temperature in a way that's different from the definition used in the Fifth Assessment Report, we need to be very careful about that, and we need to do that through a dialogue with the policy community, not just by us saying as scientists, this is the right answer, you got it wrong, now work with this one. So that's why we used the temperature definition we had, and in the point about pursuing efforts to 1.5, we interpreted that, and many others have done the same, that actually that implies aiming for 1.5 rather than necessarily aiming below 1.5. And so a lot of the paper was about, what is a trajectory and a carbon budget that gives us, in the right ballpark for 1.5 rather than necessarily guaranteeing we stay below 1.5 at a particularly high level of probability. Again, we felt that was a reasonable interpretation of what the Paris Agreement was going for. And that was why we ended up with the numbers we did. And I think, as Richard said, I think there are a number of lines of evidence pointing towards numbers like that. The most obvious one being, if we're now at 1 degree and temperatures depend to first order, and obviously other climate forces have a big role as well, but depend to first order on cumulative carbon emissions, it's not consistent with a lot of what else was, the whole notion of that dependence of temperature on cumulative carbon that we're already committed to 1.5. We've emitted 600 billion tons of carbon already. We're at 1 degree. A sort of really simple back of the envelope calculation is, so we've got another 300 or so to go. If we're 2/3 of the way there, we've got another 50% of what we've already emitted to go. Now, that's where you start, and then you ask, okay, so what do other things do, and so on as well. You mentioned the particular scenario we used. In fact, if you look at the new aggressive mitigation scenarios that people have been running since the Paris Agreement, so a lot of the integrated assessment modeling groups have been looking at, what does a really ambitious mitigation future look like. They actually come up with non-CO2 drivers of climate, so reductions in methane, reductions in other drivers of climate change that are actually more optimistic than the one we were using. So I don't think you can regard the scenario we used as an outlier. It's certainly optimistic. It suggests that we can do something about reducing these other drivers of climate change. But then, lots of other publications, notably the UNEP GAP report last year, also agreed, which I think you were a co-author on, also agreed that we could reduce warming due to non-CO2 drivers by a very substantial margin. So, the potential's out there, and which means, of course, that 1.5 degrees is not out of reach. That was the crucial message of the paper.
Okay. Thank you, Myles. I think we'll let either Glen or Gunnar respond to that before we leave the topic of temperature data sets and reference points, perhaps. Would you, I see you've been making notes here.
Yeah,
Would you like to respond?
Yeah, but I know Gunnar is going to talk more about temperature, so he will probably touch on the same point. So maybe so Gunnar can, he knows the temperature data better than me. So
should we move over to temperature, or would you like to start on the temperature part?
Yeah, I think the temperature record.
Temperature records is the topic, yeah.
So I agree that when the Paris Agreement was signed, there was no estimates of temperature in the literature. But I think it's important that that kind of information is developed and what is available of literature since the current warming, since the pre-industrial time. So that's an important topic, and there is differences in the choices. So this 0.9 estimate of temperature change, that's really important. So if you could get this figure, this shows the temperature record from 80s, 50s, 60s up to current, where we had warmest year in the record in 2016, and slightly colder in last year. And we see that we have different estimates of this. This is coming from different data centers and the way they are analyzing the temperature data. So the centers that have provided this for a long time is the NOAA, the NASA GIS, and the HADCRUT data at Hadley and University of East Anglia in UK. So this yellow data is used in the Millar et al. Paper. And you can see that the warming from this base period is more than 1 degree. And how you calculate the change then since pre-industrial, it's taken as 1860 to 1880 in this paper. But pre-industrial, there's also uncertainty what is the pre-industrial here. So that's on the left here. Or should it be 1860 to 1880? And also what you assume here. But the most important is the differences we see between the data analysis here. You can see the yellow line here is on the lower part compared to the others. And if you can get a focus on the next one, on focusing on the last 17 years, then we highlight this difference more clearly. and you can see that the Hadley data is on the lower side here compared to the other data.
But if I might just emphasize, we were not keying our study off just the observed temperatures. What we did was used a standard dating back to the 1990s approach called attribution, where we assess how do different drivers contribute to global average temperature.
Yep.
And it's very important that this spike here is mostly, the overall elevated temperature is because of human influence. But that additional temperature you see there, that additional sort of 0.2 degrees or so, is because of the El Nino that happened. So, the period which, you should be looking at is this area here, where, and we didn't actually use data beyond 2014 anyway in the study, is this area here where we were looking at the background level of human-induced warming, not the actual warming, where the data sets all give pretty much a very similar.
I partly disagree to that, because in 2017, that year is more or less not influenced by El Nino. So whether this is the normal or this was a cold period, there was also a discussion. But anyway, it will matter whether you use the head crew data or other analysis. You have even published a paper later on showing that using some of these other data sets would give a slightly larger warming than 0.9.
Yes, but also a larger warming, crucially, at the time of the structured expert dialogue.
Myles, if I may, if Gunnar can continue his line of argument, and then you guys get to respond.
But why do these data sets differ? I think that's important. And the next figure, that's a figure from the last IPCC report, showing the head crew data that is used here, comparing the NOAA and the NASA GIS analysis. And in head crew, they use data only where you have a long time series, and also how much you can, from one point measurement, how you expand that to other regions or surroundings around. So for instance, if you have a measurement here in Oslo, how much can you use that information for other parts of Norway? So, and here is a big difference between whether you use the head crew data or the NASA GIS or some of the other data sets. And importantly, the head crew data are missing out some areas where you have the largest warming, for instance in the Arctic. So that makes a difference, and so that's of the order of 0.1 degree at least, whether you choose the head crew data or others, and the head crew is on the lower side here compared to the other data sets.
All right. Thank you, Gunnar. I know Richard had asked for a comment here. Has to respond.
Yeah, so just quickly, maybe we can go back to Gunnar's first slide just really quickly. So we point out there's some difference in the data sets up the near term, but just by looking at this graph, you can actually see that by far the biggest difference actually comes from back here in the pre-1900 period. And this is because data here is very sparse. And essentially it's the choices that these data sets make about how to deal with the missing data in this really early period that is the dominant determinant of the differences. You can just see by eye that it's smaller there than they are here. And the different choices here, there's about the same amount of true data in all these data sets, and it's about what you do with these missing regions. So some data sets choose to fill in where there isn't observations using clever algorithms. That's a legitimate choice, but also I think it's a legitimate choice for policymakers to say we're just going to use the average of the points that actually are truly observed data, which is essentially pretty consistent with the Hadley Centre and is consistent with their all the way going back. So it's really what happens with this early period where there's a really large amount of data that determines the main difference in these data sets. And also finally to add, the structured expert dialogue number that we actually consistent with is actually an average of the trends in the 3 data sets that Gunnar showed on the second slide there. So it's not true that the structured expert dialogue number comes exclusively from the Hadley Centre data set. It's an average of the trends from the Hadley, the NOAA and the NASA data sets, and that's this sort of 0.85 degrees warming 1880 to 2012 trend is the average of those 3 sets, and our definition using this human-induced warming calculation is pretty consistent with that. If we use this approach of just saying let's calculate global surface temperature as it's described in the Paris Agreement as just the average, essentially, of the points where there actually is observations, which I think is a reasonable choice. It's obviously a debatable choice. There are other ways that we can account for those missing bits that we know might be warming a bit faster than the other parts of the planet, but I don't think it's necessarily a wrong choice within the context of the agreement.
Thank you. Glen had a brief comment, and then I'm going to hand it over to Myles.
Yeah, so this is a very brief comment. I think we basically are in violent agreement. There is one thing that we differ on, and that's the use of the data set from the structured expert dialogue. And I think you're going out on a limb to say that that's the data set we should use. Science progresses. If we've discovered something in 1990, that's not the number that we use in the next 100 years if knowledge progresses. And in the next assessment report, 6th assessment report, they may have new estimates, they may use different data sets, they may change this or that or the other, and what was said as 0.85 5 years ago might become something else. So I don't think that we can freeze knowledge in the structured expert dialogue, and that's what we know forever. And to say that, I think, is rather going out on a limb. I don't think that there would be many people would agree that we should freeze knowledge. And another thing, your papers, your author, using different data sets, using your attributed warming, you still come up with 1.1 roughly across different data sets. So 0.9, okay, you can take 0.9. If you want 0.9, that is okay. You just have to be clear that we've chosen 0.9. I think it's this, but for these reasons, other data sets will say it's this big, but just be extremely clear that we're taking this lower number because we think this, that, or the other. But you have to be extremely clear that your number's coming from a choice, not from the science.
Well, I mean, the opening sentence of the abstract of the paper was 0.6 degrees above the present decade. So, I mean, I don't think we could have been much clearer about what we were doing. Can I put up one of our slides, number 3 of the view graphs? If we just go on down through to the next one, please. There we are. So this does put it into context, because there was other lines of evidence that we were consistent with the information that was being provided to policymakers at the time of the Paris Agreement. So we've been talking about this structured expert dialogue. So this was the information given to the purple dot here. That was the information given to the Paris negotiators about where we were at. And, crucially, if you're trying to talk about aiming for 1.5, whether you're here, just imagine this curve. What it would be if we were already up there. It would have to be much tighter. You'd obviously have much less time to get to stabilize at 1.5 than if we're down here. And obviously if you're warming more rapidly, you'd have less time as well. So we chose it, one of the things this paper's highlighted, which has been a sort of good thing coming out of this, which, again, we commented on in the paper, and I think this has really brought it all out, is how incredibly important it is for us to be totally clear where we're at and how fast we're warming. It's something which the science community hasn't really seen as a priority up until now. Certainly the how fast are we warming has not been a question that the science community has sort of regularly addressed. That number is not in the IPCC Fifth Assessment Report, for example, because we weren't thinking in the IPCC Fifth Assessment in terms of a very ambitious near-term temperature goal. We were thinking in terms of much sort of broader questions. What is given in the Fifth Assessment Report is an assessment of the near-term expected warming for the period 2016 to 2035, and that's shown by this error bar here. And as you can see, the estimates we used, again, were going through the center of that range. So again, consistent with that other line of evidence which the IPCC Fifth Assessment had put forward for predicted near-term warming. Again, you could use a different estimate of global temperature, a different definition, which would put you through the top end of that range, but it would then be inconsistent with what had been said to the policy community about the warming to expect in the 2020s. So this paper was about reconciling these different lines of evidence, and we came up with a set which did indeed reconcile the lot in a pretty satisfactory way. If you're going to move off that, I would dispute that this is saying that science can't progress. I think you just need to say these numbers appear in a certain context, and the context of Paris was they were saying they wanted to go for 1.5 thinking they were here. If they thought they were here, would they have decided to go for 1.5? I don't know. Nobody knows. And we certainly don't want to go back and have another 10 years of negotiation to decide what the long-term temperature goal would be or would have been in the light of a different estimate of what level of warming we're at today. I mean, by the time you've done that another 10 years of negotiations, you're in a completely different place. So I think that's the context we're working in here, and that's why I think it's really important that as a science community, we do focus on this question of what level of warming are we at, and how fast are we warming? And that was exactly what this paper has highlighted.
As much as this is a very exciting debate, I would like us to also have some time to discuss the role of non-CO2 forcers, which is also a contentious issue here. So perhaps Glen or Gunnar, would you like to comment on the assumptions made in the paper when it comes to non-CO2 forcers?
Yeah, so maybe if you can bring up my slide while I'm talking. So, if you look at the literature that exists now, I think there's no arguing that RCP 2.6, the one used in your paper, is at one end of the existing literature. Maybe there's new literature comes out which is maybe more aggressive than RCP 2.6, but based on what we know at the moment, RCP 2.6, the one used in the paper, is certainly at the far end. Some would debate whether it's even possible to follow the non-CO2 in that pathway. But let's just put aside whether RCP 2.6 is aggressive or not, but let's agree that there's a lot of variation in non-CO2, and a lot of the variation you get in carbon budgets is due to non-CO2. So this figure here, which is of 2 degree scenario, 66% chance of 2 degrees. This is coming from the new scenario shared socioeconomic pathways that will be assessed in the next IPCC assessment report. This is the remaining carbon budget from 2020. Doesn't really matter what year it's from. But this is a spaghetti plot. And that's the point. There is no one number. There is no one carbon budget. If I take one model, which uses a particular non-CO2, I might get this carbon budget. If I take another model that uses another non-CO2 scenario, I might get this carbon budget. If you just click one more time, and you'll see the range just for these 2 degrees, 66% chance. Some scenarios, depending on how you want to calculate the budget, if you want to calculate the budget at this point, from this scenario or that scenario, maybe 2 degrees is 300 billion tonnes of carbon, maybe it's 1,300 tonnes of carbon. If you take a lower temperature starting point from today, and using Richard's numbers and Myles' numbers, it's up here. I'd need Al Gore's ladder to point to it. But the main point is, because of non-CO2, there is a huge range in the carbon budget. Negative emissions, which causes these curves to go up and down, causes another huge range. And you will get different sensitivities from different models. All these factors mean there's a lot of variation. If the number is up here, that is okay, but you still need to communicate strongly that there is this big range that we need to consider.
Did you want to add
to that? So, Myles or Richard, do you want to respond?
Yeah, no, I think that's absolutely right, that there is a big range of possible non-CO2 forcings in the future, and I think it's also important to distinguish things like the non-CO2 forcing, which is at least in part a human uncertainty. It's at least part associated with what we choose to do with emissions, whereas CO2-only carbon budgets are obviously some kind of physical constraint. But if we're going to consider a policy context, we need to consider them both. And in the paper, we did consider a scenario where we took the mean of a similar set of scenarios, instead of taking maybe the RCP 2.6 one. And while it can make a fractionally big difference to the remaining carbon budget, it's also important, I think, to remember what's the size of the difference in climate outcome that would come apart from that. So in the supplementary material to our paper, we considered a situation where we took the average essentially of these similar sets of non-CO2 forcings to this, and for about the same budgets as we have in the main analysis, we'd found that would result in a 1.6 degree peak warming, or warming at the end of the century. So these can have a relatively large impact on the fractional changes in remaining carbon budgets. But it's important to also remember what's the rough size of that difference. And this kind of makes sense if you think of just a 0.2 watts per square meter change in forcing. If we take a best estimate TCR of something about the transient climate response, or something about 1.6 degrees, then we're in the order of about a 0.1 degree change in peak warming associated with that. So again, the average of that with our carbon budgets would result in a best estimate 1.6 degree world using our temperature definition.
And the other really important point about this is that all of these ambitious mitigation scenarios for CO2 imply a huge amount of effort on getting down CO2 emissions. In some of the earlier scenarios, not in this set I should add, and by the way, if you look at the non-CO2 forcing in this new set of scenarios, RCP 2.6 is in the middle of the pack. In the old scenarios that we had available, in the previous set, which were available in AR5, many of them weren't really assuming much effort on mitigating non-CO2 drivers at all, which isn't very plausible. It's not very plausible that we should work really hard to reduce CO2 emissions and just let methane emissions do what they want. We might, but that would be perverse. So the point of the paper was that if you make aggressive efforts at both CO2 and non-CO2 drivers, then you still have some prospects of meeting the goals of the Paris Climate Agreement. That was at the end of the day, that was the underlying point of the paper, and the bottom line was that getting emissions to zero in about 40 years would be, if we started reductions immediately, would leave you a reasonable chance of actually meeting the Paris temperature goals, which again is not that implausible. If I could bring up those temperatures, that temperature graph again, and just show you how that fits in terms of cumulative carbon emissions, just to emphasize that the paper wasn't really saying anything particularly. If we could move on down, sorry, through that. There we are. So just hold on that one. So this just plots, again, it's just a visual, but it shows you warming to date, human-induced warming, that's the yellow line, and then just on top of that, cumulative carbon emissions under this scenario we were using. And you'll notice the sort of the yellow line and the black line pretty much track along with each other, meaning, if we're now here, and we're aiming for here, and we've used up this much of the budget, we've got that much to go. It just makes sense, because that's the way the climate system is responding. So if we're now at 1 degree, we've got roughly half as what we've already emitted to emit in the future to stay below 1.5. That, of course, leaves a huge range of uncertainty, and you have to remember that. And so if you want to guarantee staying below 1.5, there's no carbon budget left. We can't, even if we stopped emissions tomorrow, there's still some chance of going over 1.5, but this gives you a ballpark best estimate. And it's, in that context, and what this gives you is a total carbon budget that's actually around actually slightly higher than the median estimates that were coming out of the Millar et al. Paper. So there's nothing, in a sense, the numbers in the paper weren't intrinsically surprising, shouldn't really have surprised anyone in the light of this long-term relationship between cumulative carbon emissions and temperature that had been very heavily emphasized and trailed in the IPCC Fifth Assessment Report.
All right, thank you. I would personally argue that aerosol forcing is a major wild card in this whole discussion, but we don't have time to go into that. We have one final topic that we want to touch on, and that's how this paper has been received outside of the climate science community. And we're lucky to have yet another co-author with us today in the audience, Ragnhild Skeie, also a researcher at CICERO. And I wanted to ask you, as one of the co-authors, how would you like a non-scientist, a non-expert to interpret the findings of this paper? What do you want them to take away from it?
Yeah, the way I used to summarize the paper is that it took the 1.5 degree goal from being totally impossible to as good as impossible. And previously we believed that the carbon budget would be spent in only a few years, whereas this study increased the remaining budget by some more years. And now I talked about years, and the carbon budget is often presented as years. And translating, but what we are really talking about is tons of CO2. Time is not the issue here. And translating tons of CO2 into years might be effective when you are communicating the carbon budget. But when this study showed that the budget was increased by 15 years or so, that might give us the impression that we have plenty of time. And non-expert, they might think that, okay, we'll find the solution of the climate problem in 10-15 years so we can relax a bit. But there are absolutely no time to relax. And the carbon emission that has risen rapidly over the last decade must go down now and reach zero as soon as possible. And that's a huge challenge we are facing. And as stated in the paper, the pledges, the Paris pledges must be strengthened. And the Paris goal, 1.5 degree goal, is physically possible, and I think that should motivate for even further action.
Okay, thank you. It's very inspiring. Myles wants to add something to that.
No, I completely agree. Obviously, the carbon budget is about tons of carbon, and using time to convey it is not just a communication device. You know, the crucial consequence of our conclusions was that we've got of the order of 40 years to get emissions to zero. Now, that's not as bad as having 10 years to get emissions to zero, which is what the previous budget implied. But getting emissions to zero in 40 years is not going to be easy, and we never said it was. And we kept emphasizing when talking about the paper that this is a huge challenge. But crucially, if we do get emissions to zero by mid-century, we've actually got a reasonable chance of meeting the goals of the Paris Climate Agreement. And that's really important. It means Paris was a sensible agreement, not a stupid one. That's huge.
All right. I'll let Gunnar or Glen respond to this, and also if you could comment on your concerns, perhaps, about how the non-experts would interpret this paper.
Yeah, so maybe if I just start off. So one thing which you sort of mentioned just now, and also what you said before, science is not about being consistent with what policymakers think. Science is about facts and science. If it's 1.2 degrees or if it's 0.9 degrees, we talk about the fact. If 0.9 means that the Paris Agreement becomes an option with 1.5, then that's not science's job. Science is to say what the temperature is, and policymakers can do with that whatever they like with that. So I think that's an important point. So the paper, I should say, it made a lot of good contributions. I think the problems with the complex models and how to bring them together and use them for carbon budgets is quite important. We can have this discussion about 0.9 degrees, 0.6 degrees, 1.1 degrees or whatever. So it brings out that discussion, which is good, brings out the discussion of non-CO2, that is good. But I think my main problem with the paper is it didn't bring out the nuances, and I think this is why it went wild in the media, is because the nuances, the uncertainties weren't sufficiently brought out, and I think that's my main overriding concern.
All right. Richard, perhaps as the lead author of this paper, perhaps you also want to talk about how you were hoping that this would be received outside our community.
Yeah, so I think I'd echo the comments from previously that we did stress quite hard that, you know, a scenario that's even 40 years to zero is hugely ambitious, and we're certainly nowhere near that track at the moment with the pledges for 2030. You know, straight line decline between now and 2040 is certainly very ambitious, and I think we're also not even thinking about how we could get to net zero. You know, what are the technologies that's going to enable us to get there? And I think that's, for any carbon budget, that's a crucial part of it, is how we're going to actually stop emitting, no matter how long we have for it. So I think that's part of it. And then I guess sort of reflecting a little bit on the sort of the response and how it might be used outside the scientific community. I would actually disagree slightly with Glen and say that yes, science should be about laying out what these different choices are and how different methodological choices for calculating global temperature might lead us to different values. But I do think the Paris Climate Agreement isn't just a scientific agreement. I think it's a policy agreement, and the context does matter. And things like pre-industrial, again, it's not like that's a clearly defined concept that something is very absolute in science, but within UNFCCC, there's been a relatively consistent understanding of that. And I think it's important that when we're trying to provide information in the context of the agreement, that we do use the context where we can. But more widely, I think, just briefly, I think as we approach these ambitious mitigation goals, and as we sort of approach and hopefully start to reduce our emissions with some chance of getting near 1.5, then I think all these relative little factors are going to start to matter a lot more, and I think we're going to have to reflect maybe as a community and as a policy community as well about how we can best use Earth system modelling to inform pathways to these really ambitious mitigation goals, and how we can also be resilient to these uncertainties as well, because there's still big uncertainties. If we looked at the upper end of our budget ranges, they would be big, and it's sensible to be prudent and to hedge against high climate responses. But as we approach these, Paris is ultimately a temperature goal driven regime. We actually want to get beneath 1.5, not have some decent chance and then miss it. And we're going to have to think about how we can use Earth system information to refine our emissions trajectories to the extent that we can do, to try and actually get to the targets that the policymakers have set themselves.
Mm-hmm. Just to bring up one final controversial topic, so some people have argued that if you want to stay below 1.5 degrees, that means geoengineering in the form of solar radiation management is inevitable. You state very clearly in your paper that you don't think that's the case. Do you want to comment on that before we end?
Well, it's a technical, you might say it's a technical point, but in my view, it was the most important point of our paper, was that Paris did not imply you had to go for solar geoengineering. But many people were saying it did. So that was a really important point. Now, if we can't get emissions to zero by mid-century, then, we're not saying that solar radiation management will never be necessary to keep temperatures below that threshold, because it depends what happens to emissions. But crucially, it still depends on what happens to emissions. 1.5 degrees is not out of reach.
All right. I think, unless anyone has any final comments, well,
Gunnar.
Yes?
I think this paper is optimistic. We have more remaining of the carbon budget than we thought. But I think in general, the climate science community think that this number 0.9 is too low. So I think many in the climate community think that this is a bit too optimistic. So, but I think that will stimulate the climate community to work further on this and new papers and publishing more on what is the current warming compared to pre-industrial. So in that respect, I think the paper is very useful. It will stimulate debate, and look forward to the further discussion and also further IPCC reports.
Thank you. The debate here is over, but the debate itself continues, of course. Thank you all.
Thank you.